lock on.
Yeah, I know. You know when you're reading an article at night in bed like this, and it just keeps going, drives me nuts. Okay. So, we just have a couple more things I wanted to talk about in terms of acids and bases. So, yesterday we were talking about the definitions of an acid. We talked about how to determine whether or not you have a strong acid or a strong base or a weak acid or a weak base. How do you know if you have a weak acid?
I want to say it doesn't dissipate completely.
Dissociate, yeah.
Right. Oh, right.
Yeah. So, but how would you know that?
If it's not one of the sixes, that's
Yep.
what I'm...
Exactly. If it's not a strong 6, then it's weak, right?
Okay.
So if it's not strong, then it's weak. Does that make sense, guys?
Mm-hmm.
Cool. And for a weak base, this one's kind of less important because we deal more with acids than we do with bases. But for a weak base, it's the same kind of concept, right? If it's not strong, then it's weak. And what are our strong bases?
Sodium hydroxide? I can't remember. I'm trying to quiz myself as I'm doing this.
Strong bases are any group 1 metal linked up with the OH.
Yeah, baby.
Oh, from cation. Yeah.
Mm-hmm.
Cool.
Yep. Exactly, right? So if it's this, it's strong.
Oh, yeah.
Right? If not, then it's weak. Okay? Coolsies? So the next thing that we want to talk about is conjugate acid-base pairs. Do you guys mind if I erase this stuff? Cool? All right. So we have acids and bases come in pairs. Okay. Those pairs are called conjugates. Okay. Conjugates meaning partners. That's how I think of it. Right? Conjugates, like a conjugal visit, not like conjugating a verb, although maybe that's similar. I just don't know. I don't know. Okay, so when we're talking about an acid, right? Let's say we're talking about this guy. Is that a strong or a weak acid?
Strong.
It is strong. Anybody remember its name? Or have it written down? Nitric acid, right? So that's nitric acid. So we said that when this guy dissociates, we get H plus and NO3 minus, right? And we said that this is the component that's acidic, right? But we didn't name this guy. This guy would be called the conjugate base. Okay? Why would we consider this to be a base?
Because it has nitrogen. No? I thought it was if it has...
So what do we say defines a base? What do we say defines a base? Literally, the definition.
A proton acceptor.
A proton acceptor, right? Can this guy accept a proton? Yeah, right? Now that it's lost its proton, it can accept a proton, right? If it accepts a proton, it can go back to being nitric acid. Does that make sense, guys? You picking up what I'm laying down?
Yeah.
Cool. So, if we were looking at a base, and a base dissociating is going to give us sodium hydroxide, sodium ions and a hydroxide ion, right? And we said that this is the base, right? So what do you think this guy is?
Conjugate acid.
Conjugate acid, exactly. Oops, sorry. Does that make sense, guys? Kind of, sort of? So when a base is dissociated, right, you end up with the basic component, aka the thing that can accept a proton, right, and you end up with the conjugate acid. Now, generally speaking, when you have a strong acid or base, right, the conjugate base or the conjugate acid are going to be very, very weak, okay? Meaning that this guy is an extremely weak base. Extremely weak base, right? Meaning that it is very bad at picking up protons, right? And I think this hopefully makes sense because we said that this thing dissociates completely, right? So if this thing likes to break apart, then that means that this guy doesn't want to be hooked up with that hydrogen anymore. Does that make sense? Jessica, talk to me.
Oh yeah, sorry, I was writing in the margins.
Okay.
Yeah.
Is everybody tracking live with me here?
Yeah, someone
Cool.
wrote in the chat.
Oh, sorry, you guys. It's really hard for me to follow the chat when I'm doing this. What makes something a base or an acid versus adding the word conjugate? Oh, okay. So when we're talking about a base, right? A base is always a proton acceptor, right? And an acid is always a proton donor. But when we're talking about the conjugates, we're saying when this guy breaks apart, right, which is an acid, we have an acidic component, which is the H plus or the proton that it can donate. And then we have what's called a conjugate base, right? Now, it's not a very good base, but it could theoretically accept a proton, right? And go back the other direction. Does that make sense, Alex? Are you okay? Not yet. Okay, cool. So looking at this guy here, the base is the hydroxide, right? And the sodium ion would be considered the conjugate acid. Again, very weak acid, right? We know that sodium hydroxide does not, oh, I should probably turn that off. Sorry, guys.